Welcome friends! In this video I'll be looking at how to make a stovetop fan like this one. It's powered by the heat from the stove, and the idea is it blows that heat around the room, thus warming the place up quicker. So let's just have a look at the main parts. We've got the fan blades themselves. If we just come round, we can see the motor just about, and that's got a mount that attaches it to the main body down here, which is actually an old chainsaw cylinder, and that's responsible for cooling. Under that we've got the base, which transmits the heat up to the thermoelectric generator, which is this amazing magic bit that sits between the two sides, the hot side and the cold side. I won't go into how, but it creates an electric current based on the temperature differential between these two sides. Let's get to making. So I had this idea that I wanted to use a chainsaw cylinder for the cold side, or the cooler. In the past I've used CPU heat sinks to do this, and they're great at dissipating heat, so they're perfect for that job. But I thought these kind of look a bit more snazzy, and they're still finned aluminium, so they do a decent job of that. These old heat sinks here might be useful for the base. This project, like most, it sort of starts with me rummaging through bits and seeing what might be useful. That could also be a useful base or pump housing. Here's the Peltier itself with TEG, and I'm just toying with the idea of having a cylinder like this on top of the CPU heatsink for the base, and then the Peltier will go on top like that. And just kind of feeling around, thinking with my hands here. I'm going to need this little copper strip to transfer the heat from the TEG through into any of the cylinders, which obviously have a big hole in the middle. Being an excellent conductor, copper is quite good at this. So that's a rough idea for the base and body and the general shape of it. And then the motors, they're salvaged from old CD drives, both of these ones. They're both 1.5 to 3 volt. And I've used motors like this in the past, so I'm fairly sure either of these is going to work. Let's talk about the base for a moment. Its job is to reduce the temperature to protect the TEG. So temperature here is 150, and over here it's more like 250 C, that is. So you can get an idea of how much it's reducing. The last piece of this puzzle is this fan blade. Here's one I've got. It's a 4-bladed one from eBay, very cheap, £2 or so. So just by mucking about with old plumbing fittings and various scraps that I've got, I kind of worked out that this brass elbow would fit into the spark plug hole just about. So if I get it right, it will just self-thread. Of course, if I get it wrong, it will just make a mess. Something like that. Motor in there. It's not quite far enough forward, is it? So somehow or other we need to make up more distance. Let's see what tubing we can find to go in there. Only the bigger motor has a long enough shaft to actually fix onto that little hub there, so it looks like this little motor's out for now, which means I need to do a bit of modding of this thing on the lathe so the motor fits in a bit better. Essentially 24.5. I need to increase this hole a couple more. This hex nut is not going to fit well in the 4-jaw chuck, so it's time to take that off and put the 3-jaw on. It's a pretty beastly chuck, so it's best to protect the latheways with some scraps of wood just for that moment. And then we're on to a whole lot of cleaning, just getting rid of every little bit of swarf before putting the 3-jaw back on. So after doing that, here's where we are. With about 0.08 of a millimetre run out, Now I could have spent the rest of the day getting to the bottom of that and sorting the 3-jaw chuck out, but as this is not very crucial and I'm probably going to put the 4-jaw back on soon after finishing this, I just ploughed on. After that slightly diverting bit of lathe time, here we go. It's motor's fitting in there quite nicely. It's just press fitted at the moment. The problem I've got now is that when I put this on and I screw it up any significant amount, say to there, which is still a bit sort of loose and wobbly, the blade's now snagging. Leaves me with the option of either grinding some off that, which I don't want to do really, because it'll change the sort of look of things and then I'll be tempted to grind it all and that'll take days. So I'm left with kind of needing to make some kind of extension piece for this. Back to the lathe. So I found this bit of brass scrap that's from an old garden hose connector that was broken, and I thought this would be perfect, but I turned it down and then this happened. Yeah, shit, I didn't account for that little indent there where the material is a lot thinner. So I had to abandon that brass piece altogether. I found a different bit of steel pipe thing, and that actually worked quite well. I turned it down on the lathe, and all I'm doing now is just milling a little relief for the wires to go from the motor, and they'll go through that hole, down the brass elbow, and through the cylinder bore, and to the peltier. Great, okay, good. We're now missing, we have clearance. Now I just want a way to fix the motor into that little extension piece, and I'm just drilling and tapping a hole for a set screw to go in there. So, should have a locking screw. With that all working and the extension piece kind of working nicely, I thought it was now time to thread the wires through and solder them together. I'm not sure if it makes any difference, but as far as I can tell, the stamped upon side is going to go to the cold side. The wires are so it's going to go like that. And then I just need a base, so I can see which direction this motor is going to spin in. I've got it hooked up with crocodile clips. That's the thing I'm thinking about using as a base. It's just been on the stove top, so it's quite warm. There's something cold on. And you can see it works. And it's going... Well, it works with a bit more torque than I'd imagined. And it's going that direction. That way round, which will be pushing the air forwards, which is drawing it through the heatsink, which is what we want. If it wasn't going the right way, then obviously I'd just switch those leads around with the crocodile clips. As it was good, so that could be soldered up. Essentially what we need to do is just mark out 4 holes to line up with this, drill and tap them, connect it all up, try it out. Whoops. We're very nearly ready for final assembly, I think, so I'll just give this a little try. Give this a little in. So after cleaning off all that old thermal compound, it's time to assemble it. I'm just using little springs between the bolts and the main body, and that just gives constant but not excessive pressure sandwiching the peltier. Okay, we're starting to get somewhere. As you can see, it's just spinning up now. The fire's just been lit not long ago, so it's only at about 150 degrees ish, I think, on the surface plate, which probably means it's like about 50 degrees at the hot side of the Peltier once the heat's come up that base. So I've just changed the fan blade itself here. I'm trying out this one. I'm not sure which one I prefer really. This one's a bit more kind of Blade Runner, whereas the other one's a bit more like Transformers-y. I think that about wraps it up. If you decide to make one of these, I'd love to hear about it, or if you've made one, let me know in the comments. If you're intrigued about the sideways burning experimental stove you can see in this video, you can check that out in my previous video. Apart from that, thanks for watching, share and subscribe, and I'll see you next time.